Welcome to the West Button CCGT project.
One of the largest construction projects in the UK.
We're building this power station for EDF Energy.
With nearly 2,000 people on site.
That's a lot of people and a lot of energy.
Firstly, I'd like to welcome anybody who joins this project to our team, which is the West Burton CCGT project team. The CCGT stands for Combined Cycle Gas Turbine. This is a big project. We're building 3 units on site, generating an overall output of 1,311 megawatts, enough power to deliver power to 1.5 million homes. Gas-fired power stations are much more efficient and clean than coal. This development is part of our targets to reduce the intensity of our carbon emissions by 60%. There are a number of companies working on site. The main design work is being delivered by EDF, CIT, which is the Centre Engineering Thermique based out of Paris. They have provided all of the overall design for the power station and also the on-site principal contractor role who manage and coordinate the main site activities.
We started the middle of 2008 with the main civil activities. Electromechanical activities starting in the spring of 2009. We are currently in the peak of electromechanical activities, starting commissioning, and the target is to have first unit on the grid by the middle of 2011, unit 2 and 3 following end of 2011 and beginning of 2012.
The civil works have been undertaken by Kier Construction. The main mechanical and electrical is being undertaken by AMEC in now an alliance with EDF CIT.
EDF are very much a technically oriented company. They have very good technical skills. If you look at AMEC, they have more focus on the construction know-how. So by bringing the two teams together, you're getting a much better benefit in terms of the value of those joint resources.
This project is incredibly important to me personally and to EDF Energy, and there's a huge sense of pride for me seeing this power station come to fruition.
The challenges we are facing are making it more interesting, more rewarding. People can be proud to be part of a big team.
I take great pride in what we have achieved and what we will achieve together.
My name's Andy Lowe. For those of you who haven't worked on a CCGT station before, this is it. And I'm going to show you how it works. It all starts with gas. We've built a 19-kilometre pipeline from a place called Grayingham, north of Gainsborough, and it arrives on site through a 24-inch diameter pipe under the River Trent to the gas reception facility. Here, the gas is metered, filtered, pressure reduced, and then reheated for consumption in the gas turbines. On average, each gas turbine will consume 250,000 metres cubed of gas per hour. Here we are in the heart of the power station, the gas turbine, which is essentially a jet engine on a massive scale. Air is drawn through the filter into the compressor, where it's compressed, mixed with the fuel gas and ignited to drive a power turbine. That power turbine operates at 3,000 revs per minute, turning the generator to produce 290 megawatts. This is the next phase in the process. This is the heat recovery steam generator, or HRSG for short. And this is what makes the CCGT process so efficient. It takes waste heat out of the gas turbine exhaust and uses that heat to convert water into steam. Once that steam has been heated to 565 degrees C, and 120 bar pressure, it's conveyed onward to the steam turbine. Steam from the HRSG passes through the steam turbine, and that is used to generate electricity in the generator behind me. Once the steam has lost its energy, it's then condensed into water in the condenser for reuse. Having condensed the steam in the turbine, the cooling water needs cooling itself, and that takes place here in these hybrid towers. We have 3 units, each with 10 cells. The water falls through the cooling towers and is cooled by an updraft of air. Unlike the A station, where that draft is created by the size and shape of the tower, here it's induced by these large fans. And that's why we can design the towers that much smaller. This is the last part of the process. where we export power to the national grid. Power from both the steam turbine generator and the gas turbine generator comes out into the transformers. Voltage is lifted from 17,000 volts up to 400,000 volts, comes across the overhead lines into the switchyard and out through the 2 underground circuits. In effect, we've gone from 1 2-foot gas pipeline at the start of the process to 6 underground cables at the end of the process, and we've got all this in between.